With the fourth Starship flight on the horizon, all eyes are on SpaceX as they tackle the pressing issue of Starship's heat shield. As this launch marks a crucial step in demonstrating Starship's reusability, SpaceX, led by Elon Musk, has been diligently working on implementing major solutions to strengthen the heat shield. Let's explore the exciting advancements they've made for this upcoming mission. The primary technical obstacle remaining for Starship is its heat shield. This declaration underscores the essential requirement for Starship's perfection, with the heat shield being a major concern for space enthusiasts. The issue arises from instances where heat shields have detached due to the intense vibrations from the powerful Raptor engines during tests. While such incidents are more common than perceived, SpaceX has been addressing them, albeit perhaps not with the same level of focus as other components like engine and fuel pump systems. Additionally, the lack of real impact scenarios for Starship and its failure to reach orbit during initial launches have limited opportunities to fully assess the heat shield's endurance during reentry. During the third Starship launch, IF-3, SpaceX engineers acknowledged the significant issue with the heat shields upon re-entry into the atmosphere. Now, with the fourth flight, improvements have been implemented by SpaceX and Elon Musk to address this problem, ensuring a more successful outcome for the mission. Ship 29, positioned atop Booster 11, underwent a month-long examination by SpaceX, particularly focusing on its heat shield tiles. The assessment revealed notable differences in the new tiles on the nose cone compared to previous ones, indicating technological advancements by SpaceX. While heat resistance, lightness, and reliability are key concerns for heat shields, ensuring the adhesion of tiles is paramount. Even a single broken or dislodged tile can render the heat shield ineffective, often caused by vibrations leading to collisions and subsequent damage. To address the heat shield challenge, SpaceX is considering various solutions. These include adjusting tile spacing and shape, and potentially adopting a pyramid-like protrusion to disturb plasma flow away from the spacecraft. Enhancing surface roughness, akin to shark skin, could improve aerodynamics, with simulations guiding the optimal roughness height. Smaller tiles, especially at critical joints, are under consideration to mitigate vibration issues. Introducing a water cooling system offers further potential solutions. Concerns about mounting pins causing tile cracks prompt a focus on attachment mechanisms. SpaceX aims to upgrade these mechanisms, refining mounting pins and using a new adhesive, possibly a red glue replacing the previous blue one. All these efforts are geared towards ensuring that the tiles remain securely attached under the extreme mechanical and thermal pressures experienced during re-entry. So why doesn't SpaceX opt to solely use glue or metal pins for the entire Starship rocket? It seems they've chosen a combination approach. The nose cone and leading wing edges of the Starship are crucial for aerodynamics, thermal protection, and overall performance during entry into the atmosphere and flight. Using metal pins in these areas could disrupt the spacecraft's aerodynamic profile, leading to increased drag during entry. On the other hand, adhesive bonds create a smoother surface, reducing aerodynamic disturbances and optimizing spacecraft performance during re-entry. Additionally, adhesive helps distribute heat more evenly across the heat shield tiles, enhancing their thermal protection capabilities during re-entry. It also prevents hot gases from seeping between the tiles and the spacecraft structure. But is there any reason not to use glue on the entire prototype? Using glue on the entire front surface of the ship is impractical due to time consumption, potential cracking affecting serviceability, and increased fuel requirements for cooling, which would add to the spacecraft's mass. Despite the advanced thermal protection system of Starship, SpaceX continues to face difficulties in securely connecting heat shield tiles to the vehicle's body. This highlights the complexity of the task and underscores the ongoing efforts to find effective solutions for this critical aspect of spacecraft design and operation. SpaceX's heat shield tiles, inspired by those from the space shuttle era, are lightweight but challenging to attach securely due to their porous nature. Initially using a combination of smooth pins and adhesive, SpaceX has shifted more towards metal pins for attachment. However, this change reduces the surface area in contact with the tiles, posing potential weakening concerns. Despite ongoing challenges, SpaceX is dedicated to enhancing the attachment process for these critical components. Despite facing many hurdles in refining its thermal protection system, the Starship team leverages NASA's space shuttle technology to enhance and refine its TPS. Starship's design prioritizes rapid reusability, enabling swift turnaround times between missions. Both Starship and the space shuttle rely on a durable insulating shield, as replacing the entire thermal protection system after each mission isn't practical. They both employ black heat shield tiles, contrary to the expectation that reflective coatings would be more effective at deflecting heat. This decision is because the main heat threat during re-entry arises from the plasma shockwave generated when the spacecraft enters the atmosphere at hypersonic speeds. Temperatures beneath the spacecraft during re-entry can soar to 2300 degrees Fahrenheit or 1260 degrees Celsius. The black appearance of the shuttle tiles is due to a borosilicate glass coating known for its low thermal expansion coefficient. In areas with less intense heat, white tiles are used to optimize thermal properties. During its time in orbit, NASA's shuttle program faced notable challenges with its thermal protection system, including bonding difficulties between tiles and the hull, as well as instances of tiles coming loose during launch. These issues, coupled with the extensive maintenance needed between flights, affected the shuttle's reputation for rapid reusability. Some of these challenges resulted in catastrophic outcomes, providing valuable lessons for future spacecraft like SpaceX's Starship and Sierra Space's Dream Chaser. Unlike the shuttle, which was prone to impacts from foam and ice debris due to its side-mounted position on the external tank, Starship's design places the upper stage at the top and the lower stage at the bottom, mitigating this risk. Additionally, the shuttle's intricate structure necessitated various thermo-tile shapes, complicating and increasing the cost of their replacement. In contrast, Starship features a simplified design with just two main types of heat shield tiles, thinner and thicker star bricks. Understanding the complexity of spacecraft heat shields, we anticipate Space's upcoming launch, with hopes for a successful re-entry of Starship back to Earth. That's all for this video.